Hi, welcome back. Today we are going to talk about feedback system and introduce the software tool called Stellar. I'm not going to go to the detail how to use the software tool. And after the class, you can either get help from myself in my office hours or anytime with the appointment, or my graduate assistant, Jason, can help you for the details. So today, first I'm going to introduce the open loop and closed loop systems. And we can call it a feedback system in some sense. And then I'm going to introduce Stellar by the philosophical level to see the icon semantics and the basic syntax. And then I'm going to show you one example to solve a double tank fluid problem and go through the validation and verification. Well, what is an open loop system? An open loop system is very simple. You can draw it like this. You have the input, and any system, you can think about a signal processing system. In here, once it gets to the input, it either amplifies it or transforms the signal, like change from digital to analogical or analogical to digital, DAC, ADC, such as here, or amplify. Whatever process you do here, we call it a control. And then you get the output. And that's an open loop control. But in the real world mechatronic application, they are rarely like this. Instead, they are closed loop system. Well, I would like to see if you get the answer for the question we asked last time. Let me remind what is the question I asked in last lesson. Do you remember we have this simulation how to mix the sugar and turn on this switch, the faucet, and then turn off? I asked you the question, how many flows you have seen? So, of course, you see the water flow down this way, and you probably paid attention. I turned off this switch, and you can see the water maybe even come down this way. But that's not what I'm really asking you. I want you to identify two loops, two flows. And let me give you an illustration, what you need to see. So you all see, you saw this is the pipe, and here you have a switch, and this is my hand. Okay, so hold this switch, and the water goes down from here. Let me draw the water, maybe a different color. I don't know what is green. Well, we have a cup, hold the water, and here you go. That's what you maybe see. The water is flowing from the pipe to the cup. Well, I bet you all have seen this. My real question is, the other flow, people did not pay attention. So the best illustration, let me use red to emphasize. Here, you know I turn on and turn off, but what made me turn it on and turn it off? The next one is really a information flow, and what is here is the eye. And my eye constantly watch the level of the water. And then, once the water is full, the information goes, of course, from my brain to the hand. I turn it off. So in this picture, you clearly see the philosophy of a feedback system. You have this, we call it material flow, which in here is the water. And in last time, when we talk about the brain mixing, and that's the salt. But the second one is here. This one is really the information flow. In any control system, is the information really give the signal to control, like turn on and turn off, turn faster, turn slow, and to control this material flow. Now, once you understand this philosophy, it's easier for us to understand what is real a closed loop, or we call it feedback control system. Well, different from this system, and you get the output here, the real difference is we have a desired target. Let's say this is the desired target. How about think about a missile tracing system? And then here you get an observation, and then information flow here to the control. And then you get the result of your control. Well, if information just flow in this direction, that's still an open loop system. But the difference is we need to measure or censor the real result, and the brain the measured or censored information about the result back into the monitor. And then the input will be adjusted by looking at the difference between your desired target and your actual target. And then you're going to adjust your control action and then to get closer to your result. Well, let me give you a cruise control example. Let's say a cruise control. Now, if you set your target speed as 70 miles per hour, on the highway, and the cruise control system really started to increase or decrease. It really depends on the measured speed. If it's 50 miles per hour right now, and then you need 70 miles per hour, and then the information here means you need to speed up, and then the acceleration pedal will push further down, and until, let's say, the next measurement is 60 miles per hour, and then you find that this is still slower than you desired, then it further push down. Maybe after a few rounds, you measure that the speed is 72 miles per hour. Well, when you compare, now you know you are over speed, and then you will be speed down and decelerate. So that's kind of a closed loop. And the closed loop have both the control loop and the information loop. So a little more detailed pictures here in the robotic project. You all know those things. You have sensors to really sense the output, may not like what you said here. And those sensors give the feedback system to that we call the summing junction. Basically, that's the decision point. And then push the arrow to here, the controller, usually, if we use the differential equation by Newton's law, this is the inertia times the double derivative equals negative of this arrow times some constant maybe. That's a typical controller, and we call it a negative controller system. Okay, now what's the relationship with the stellar? You're going to find it soon. Stellar really treat the every system as a closed loop feedback system.